Hello, friends. Welcome to a very important session in which I would be explaining you about big data and Apache Hadoop. In this session, I would be explaining you about the in and out about what big data is and how Apache Hadoop helps in processing this big data. So what a big data is. Now, as you know that every now and then people are speaking about this word big data, big data. What this big data is? Okay, it simply means lots and lots of data. Okay, data in terms of terabytes and petabytes is considered to be as big data. Okay, but how did this term big data came into picture? Okay, you know that astronomers, they do a lot of analyzing uh, data. Okay, so while analyzing data, okay, the data is nothing but the data that has got generated by their satellite sensors. Okay, so astronomers keep working on such data. So they came up with this term, what is called as big data. Okay, so instead of calling, because the data whatever was getting generated, it was huge. Okay, so they didn't had any other term rather than saying it as big data. Okay, and in common terms, you need to understand what is lots and lots of data, that is data in terms of terabytes, petabytes, is considered to be as big data. Okay, now if you consider the day-to-day life, every day 2.5 quintillions bytes of data is getting generated. Okay, you can't imagine like 2.5 quintillions bytes of data, right? So big data is a term for collection of data sets so large and complex. Okay, I'm not saying that the data sets or the data that is getting generated is not only large but also it is complex. Okay, so it is so large and complex that it's difficult to process such data on traditional RDBMS. Okay, you cannot process such huge data on your RDBMS platforms like your Oracle, MySQL, which allow you to store only structured data. Okay, and as you know, as once again stressing that most of the data is unstructured. It is large, complex, as well as unstructured. Why I said that it is difficult to process such data on the traditional RDBMS, because data is unstructured. RDBMS allows you to store only structured data. Okay, and you know what? That if you consider the whole world's data, okay, if you consider the whole world's data, as you know that data is having a unit called byte. Okay, so if you consider the whole world's data, that is the data that started getting generated from the uh, our ancestors. Okay, so if you consider that whole data as 100%, out of that 100%, 80 to 90% of the data is has got just created last 2 years, within last 2 to 3 years. See the impact of the social networking sites that we use. Okay, so out of that 100% of data, the data that has got generated in the last 2 3 years only comprise of 90%, 80 to 90%. So just imagine what type of data it is getting generated. Okay, and if we go further for years to come, this 90% will go on increasing. Okay, so data is getting generated exponentially, to tell you the fact. Now, why do we need this big data? Okay, we need it for analysis purposes. Okay, now if we want to examine large amount of data, and if you want to know how to go about a business and about marketing, about customer satisfaction. Okay, now you might have seen on some of the uh, online sites. Okay, you have an option called feedback. Okay, so those vendors, they do what is they collect the feedback of the various customers. Okay, and they then plan for the next product. Okay, now if a product is launched, people go on giving feedback that whether this product is good or bad. And also you can see online if you are going for online marketing, if you want to buy a laptop or a mobile phone, you first check out for the reviews. Okay, so you check for the reviews. If you find that the reviews are positive, you go for the buying of the product. Okay, so that is where this big data, okay, the reviews, the tweets, if you consider the tweets in Twitter, the Facebook comments, those all are what the data. Okay, if you consider that kind of data, okay, it is huge data. Okay, so we need to know what the comments are. Okay, that is what is called as analyzing. Okay, so big data is used for analyzing purpose. Okay, there are many more examples in the due course of this session. Okay, I'll be explaining you many more examples. So applications of big data analytics, okay, you have so many applications, okay, in manufacturing, traffic control, telecom, there are many, fraud and race, right? So there are many applications. So what are the sources of big data? Okay, now if you consider our social networking sites like Facebook, Twitter, okay, if you just consider Facebook, Facebook itself generates 250 to 300 terabytes of data every day. Just imagine 250 to 300 terabytes of data every day. Okay, you know that 1000 MB is 1 GB and 1000 GB is 1 TB. Okay, and such such 250 terabytes of data just Facebook alone generates. Now, I hope so. This is not the actual figure. Now, the figure has gone up. Maybe 500 terabytes of data is getting generated every day. Why? Why such data is getting generated? As you know, there are so many customers of Facebook. There are so many users of Facebook. Okay, so every user, if he is having an account, he'll not sit quiet. He'll be always uploading some text information, some audio information, some video, some uh, movie clips, maybe some pictures. Okay, so all such data, if one user is uploading, just for example, if one user is uploading some MB of data, then there are crores of users all over the world who are subscribed to Facebook. So if everybody is uploading the data, then the data that is getting generated would be obviously huge. Okay, so that is what is called as big data. Okay, now on the same lines, if you consider this New York Stock Exchange, okay, it generates 1 terabytes of new trade data per day. Okay, so new trade data itself is 1 terabyte. Okay, this might be, again I'm saying, this might be, it might be not the correct figure, it might be something 5 terabytes of new trade data. Okay, so that's another example. The stock exchange, the weather forecast, okay, if you consider the data, okay, generated by the sensors, okay, which are associated with weather forecasting, they also get generate data. Okay, that is also huge data. Okay, now email servers, okay, they also generate data. Logs that are associated with email server, they are also big data. Medical data, that is again logs created by those machineries used in medical terms or medical field. Okay, they also generate logs, they are also big data. Now for example, if you consider aeroplane, okay, a plane, once if it takes off and when it lands, it also generates data. Okay, data generated by the sensors which are available in the plane. Okay, so that data, what we call as like a black box available in plane. Okay, so that data will be generated in the black box of the plane. Okay, so that is also big data. Okay, so these are the various sources of big data. Okay, Twitter, Facebook, okay, those are social networking sites. They also generate a huge amount of data. Okay, now if you consider the unstructured data growth, okay, see this is the business transaction data, okay, the blue one, and the application data, that is the pink one. Okay, so this data that is available in the form of pink color, okay, is the data that we are speaking about. Okay, see the growth of this pink data, okay, or the application data, okay, that is nothing but big data. It is complex and unstructured. and this data that is available as blue is our relational data. Okay, so its growth is constant. Okay, it's not exponential. But if you consider this complex big data, okay, which are the data from various sources like Facebook, Twitters, okay, it's huge. Okay, so by the time of 2020 we need a lot of storage spaces and clusters, okay, to in order to store huge data. Okay, now IBM characterization of big data. Okay, we have IBM's definition of what big data is. Okay, they have categorized which data should be considered as big data. Okay, now coming to one by one. Now volume. Okay, as I said, data in terms of terabytes, petabytes, and hexabytes. Okay, if that sort of data it is, then it is big data. Okay, then when we consider variety, okay, as I said, an example about Facebook. Okay, Facebook has got uh, text information, audio information, video information, picture information, so it's a variety of data. Okay, so that kind of data, and also big data, huge data, that's also a big data. Okay, and velocity, as you know that just now I mentioned that in Facebook, okay, the data is getting generated in the terms of 250 to 300 terabytes of data. Okay, so the pace at which the data is growing is called velocity. If the data has got high pace, then it is again big data. Okay, and next is veracity. Okay, some of the data, if you consider that is big data, if you consider there are some fields that are not uh, consistent, or there are some fields that are ambiguous, or maybe they are doubtful fields. Okay, if you consider a table, in a table if you have an attribute, for example, the second address of an employee, okay, that second address is most of the time empty, because no employee can have two addresses. Most of the employees will not have two addresses, except some of the employees. So for most of the employees, that second address attribute will always be empty. So such kind of data is called as veracity data. Okay, and also you can take an example of a sparse matrix, wherein there are many fields which are null values. Okay, so volume, veracity, variety, velocity, and also we have latest one which is added to this characterization, that is value. Okay, now when we speak about this big data, okay, it's a valuable data, because using that big data we come to a conclusion. Okay, if you consider stock market, we can take the data that was generated for the previous product, okay, and analyze how its growth was, then we can make a decision for the new product. Okay, so the data whatever was generated for the previous product is a valuable product, valuable data. Okay, so value is one more thing added to the characterization of big data. Okay, so IBM's characterization of big data is five V's. Five V's. Now, common big data customers are like web and e-tailing, telecommunications. There are many who actually make use of this big data analysis. Okay. Now, now we'll move further with. Now I hope you people have understood what big data is. Now we'll move further with what is the tool that will help you to process this big data. Okay, as I said that it is not possible by RDBMS to process such huge data. So there should be some tool that will allow you to process such huge data. Okay, so the tool is Hadoop. Okay, so the tool which is available for processing huge data is Hadoop. Okay, what Hadoop is? Hadoop is a framework that allows for distributed processing of large data, okay, across clusters using a simple programming model. Okay, that programming model is called MapReduce. Okay, so in the next coming slides I'll be explaining you what MapReduce is. Okay, so one thing you understand that Hadoop is a framework, okay, that allows for distributed processing or parallel processing, okay, of this data across clusters. Okay, so if you come uh, across this term cluster, you mean that there are n number of machines connected to each other and providing parallel processing. Okay, so Hadoop is a open source data management with scale out storage and distributed processing. Okay, one thing simple, Hadoop is a framework that allows for distributed processing across the cluster using simple programming model called MapReduce. Okay, so when I say distributed processing, okay, it is done through the programming model called MapReduce. Okay, now why this distributed processing is needed? We'll take an example. Okay, suppose there is a situation of reading 1 TB of data. Okay, and this is one machine, okay, which has 4 IO channels. Each channel is capable of 100 Mbps. Okay, so if you want to read 1 terabyte of data on this machine, okay, which has got 4 IO channels and each channel having capability of 100 Mbps, it will take 45 minutes. 45 minutes it will a single machine takes to read just 1 terabyte of data. Okay, so we'll go further with